Just see this is the unit 1. Okay, we have completed all the topics of unit 1. Correct. Now today we will discuss unit 2. Okay, we'll discuss regarding some topic like what are the solution and at least one method. Okay, so any doubt? Okay, fine. So unit 1 we have completed. Any comments on that or any query? Okay, fine. So now we'll move to unit 2. Correct. So unit 2. Okay, unit 2, I'll close this one. Unit 2, first one is numerical solution of algebraic and transcendental equations. Okay, I have already discussed in the introduction class. In the introduction class, what we have to do actually here in this unit 2. Okay, once again I will discuss. Before that I will close this one. You want to save? No. Okay. Okay, so now how many are there? 26. That means 24. Okay. Okay, fine. So now today's topic. Okay, solution of algebraic sorry, solution of solution of algebraic equation. Okay, and transcendental equation. This type of two equations only will. Okay, this one we will consider as equations. Okay, so already we have discussed. Okay, now if I ask you to solve this one, x square plus 2y x or 2x plus 1 equals to 0, you can find the solution easily. Okay, and if I ask x square minus 2x plus 1, then also you can solve. Correct. Now if we consider this type of equation, plus 2x log of x plus 1 equals to 0, then it will be a problem for us to solve using the traditional equation. Okay, sorry, traditional systems or traditional methods. Clear? So for this type of problem, okay, but we need actually solution for the applications of different applications of new engineering problem. Okay, you need the solution. So what is the solution? What is the solution of that one? Okay, can you find the solution of this one, that box equation? What is the method? If you are able to solve, what is the method? Anyone? Have you studied earlier? Okay, so x square, but if you remove tan x and log x, then you can solve. Correct? No? You can solve using that one. So that's why if you now if I ask you to write down what is the x, okay, then it's really tough to find from this type of equation, but here you can write easily. What is that one? 1, na? 1 and 1 repeated solution. Correct? So x minus 1 at whole square equals to 0. Here it is x plus 1 at whole square equals to 0. That means x is equals to, okay, minus 1 and minus 1, like that. Correct? So repeated solution. So you can find. But what about this one? What is the solution of this equation? So, but you need the solution exact. maybe exact solution or very close to the exact solution. So to find the solution of this type of problem, okay, now, which is not able to solve using the traditional method, then you have to apply numerical techniques. Okay, by applying numerical techniques, you can solve or you can find the solution. What happened? Oh, I see. What happened? Okay, now what is the solution? So we have to apply numerical techniques. Okay, we need solution. Definitely we need solution for this type of equation for your engineering applications, correct? So we have to apply, okay, we need solution, so we have to apply, we can apply numerical, we can apply numerical techniques. Okay, what are the numerical techniques? So first one is, for this type of case, algebraic equation, we have lot of techniques. First one is bisection method. Okay, so bisection method. Okay, I will write the steps later on. Okay, bisection method. Okay, this is the bisection method. What is the meaning of this term? Hello. Part 2 part. Fine. So this is one. Okay. This is the length. You have to, if you make half of this one, that means you are bisecting these two in a two part. Correct. Now, just see. Doing this one. Find coordinate axis, x and y. Correct. Say the solution in terms of y equals to something, y equals to f of x. So earlier description like that, x square minus 2x plus 1 equals to 0. This one we can write f of x equals to 0. That implies y equals to 0. Where? Okay, y equals to f of x. Fine. So our target is to find f of x equals to 0. So what is the meaning? We can write x square minus 2x plus 1 equals to 0. Fine. So that is f of x equals to 0. Fine. So now this one, this is fine. Say what is this 2x f of x equals to 0? What is that? F of x is a curve. Fine. F of x equals to 0 equation. Correct. So now let us consider this way. This is the curve, say y equals to f of x. Fine. Y equals to f of x. Okay. Now it is given that you have to find a solution of this equation. What is the root and what is solution? I should not discuss this one, you know, I think so. Okay. What about the solution? What is the difference, or both are same? Any comments on that? If you have anyone? Okay. We'll discuss later on. I'll discuss this one later on. Okay. Now, first of all, y equals to f of x. That means f of x equals to 0. You can find one root. Okay. Now, one root of this equation, or this one root. So what is that one? say x equals to x1. X equals to x1 is the root, correct? And now just tell me, I have already drawn one graph y equals to f of x. How many roots are there?
Only one, sir.
Okay, what is your roll number?
29, sir.
29. Can you explain what is root now? Please explain what is root. But an easy one, okay. Okay, what is your roll number? 42. Fine. Good. Now, what is the root of this curve? Why? No, not that curve. Now, just I have drawn another curve. Okay. So green one. What is the root?
No root, sir.
Then, okay. Fine. No root. Okay. So now you have one root, correct? For this curve, you have one root. Fine. So according to that one, that means the curve. Okay. According to you, the curve crosses the x-axis. Okay. Anybody, any other can give some more input on that? Any other input? Not more. Any other input on that? What is solution? What is the root? Sorry, what is the root? Okay. Okay. Okay, fine. Fine. So if equals to 0, that is the root, correct? Okay, fine. Now for this graph, okay, now this curve y equals to f of x, correct? You are already one of your friends already informed that there's only one solution, one root, correct? Only one root. Fine. I also agree with that one. I think you also agree with this one. Okay, only one root. Now, actually, that means the curve y equals to f of x crosses the x-axis or touches the x-axis. That is also root. Fine. For example, okay, this curve having how many roots? One root. So it may not means no need to say that it should cross it. Correct? Na? It can touch x-axis. Correct. Any other form? So it is cross or touch. That is one concept. Any other concept? What is root? Mathematical concept. Oh, fine. What is your roll number? 42. Fine. Okay. So now, fine. That is okay. All this in that concept we will use. Okay, within a few minutes. Just wait. So let us consider now the interval. So this is initially I have already given this the length. So let us consider this is A and B. However, A equals to 0 according to my drawing. Fine. So if I shift the y-axis here, then it is not 0. Fine. Now it is not 0. It's okay. Now it is not A is 0. Fine. Okay. So now this is actually initially we have told this is A. So now, so how many roots are there between A and B? 1. Fine. What is the f of a value? Quick. Answer should be there. Quick. I have to. No. Forget about this one. Okay, now say y equals to f of x. Yeah, fine. I have to change this one. Now f of x is any curve. Okay, f of x is any curve. As per our discussion, we know the root. Okay, so as per our discussion, we know the root. What is root? The root is f of x equals to 0. Okay, for what value of x? That one we have to find. That are the roots. Okay, these are the roots. Now, just from the figure A to B, what is f of A? So graphically, if we say this is this is f of A. Fine. What is that? Now perpendicular distance from the point A to the curve y equals to f of x. Am I correct?
Yes, sir.
Yeah. What is f of b? This is f of b. Okay, now. So let us see. This is f of b. I have to erase again. I will change the position. Now it is say b. Okay. So that it will be like that. So what is b? F of b. F of b is the perpendicular distance from the point B, from the axis x to the curve, that one. So this is perpendicular distance. Fine. Okay. What is the sign of f of a? This is one measurement, distance. So distance can should not be negative or positive. It's a quantity. Now what is the sign of f of a? The distance. It is actually y-axis in the sense of positive or negative. If this one is x-axis and this one is y-axis, then what is f of a? Negative. And what is f of b? Positive in the sense. Correct, na? It is y x dashed y dashed. Fine. Now if you product f of a into f of b, what is the meaning? So it is less than 0. Actually, this is the condition that at least one root, at least one root exists, okay, in the interval a comma b. Fine. What is the condition? Now f of a into f of b less than 0. Correct? Okay. So now we are going to discuss this bisection method. So now this is the total length we have considered. Now let us consider this is the middle. Okay, this is the middle. So it is say x1. Okay. So at x1, what is x1? What is x1? A plus b by 2, middle point. Okay. So now middle point, what is the value of f of x1? Positive or negative?
Positive, sir.
Positive. Okay. So now if you consider this one as f of a, sorry, f of x, so let us consider that one. Okay. So now this is the equation, sorry, this is the condition. Now f of x1 is greater than 0. Now f of a into f of x1 and f of x1 into f of b. What is this one? It is greater than 0. This one is less than 0. Fine.
Reverse, sir.
Reverse. Okay. Fine. So it is not correct. So reverse, it is less than 0. What is the conclusion from these two? What about the sorry, greater than 0? What is the conclusion? What will be, according to this statement, what what will be the conclusion regarding this f of x1 into f of b? That means, is there any root between x1 and b? No root exists. Okay, now root exists. Yeah, a root does not exist between these two. So what is this one? This is this one and this one. There is no root. But root lies between a and x1. Fine. So this is in the interval a comma x1. At least one, the same comment. Okay, now at least one root exists. Correct. So now you can discard this one, that interval x1 comma b. Now your new interval is a comma x1. Okay. Now new interval is a comma x1. Fine. So I will erase the rest part. Okay. So I will erase this all the part. Okay, now here. Okay. Just see. So now this is meaningless, already discussed. Okay. This one I will erase this one. Fine. Okay. Now what is this one? Okay. Okay. Now just see the root lies between x1, a and x1. Fine. A and x1. Okay, y equals to f of x, that one. Now earlier it was a comma b. Now it is shifting, the root shifting actually root is not shifting, the interval is shifting from a1 a comma b to x1. Now you consider a plus x1 by 2 bisects the length a to x1, just bisect it. Let us see, it is x2. So let us consider this is the x2. Okay. So now just see this one actually a earlier. Now it is x2. Can you answer the root now? The root lies between which interval now? Either 8, so x2 is a plus x1 by 2. So two options are there. Okay, a comma x2, another one is x2 comma x1. Fine. Now the root lies between which interval? A to x1 or x2 to x1? x2 and x1. Fine. So the root does not belongs to this one, so I will erase this one. Fine. So what is x2? x2 is a plus x1 by 2. Okay. So now you just see the interval. This is the interval. Okay, now from here to here, what actually you have noticed? Initial interval was this one. Now next time it was reduced to this one. Okay, I will use different color. So later it reduced to this one, and now the new interval is this one. Fine. So what is happening actually? Using the bisection method means you are bisecting the length of the x-axis, and actually the length of that interval is reducing, and ultimately if you continue that process you will reach here. At that point the root exists. Fine. So what will be the working formula for that? That means we are considering this one, x is like that, a plus b by 2. A is one point, b is another point, where f of a into f of b is actually giving different, it means opposite sign. One is positive and another is negative. So general form we can write xn plus 1 an plus bn by 2, this one. Of course the f of an into f of bn should be less than 0, then only you can. So this is the working formula. Till now I have not discussed regarding the steps and the fundamental of that one. And few more. Okay, now. So, but the techniques behind the techniques, this is the concept. Okay, that concept we have already discussed this one. So initial one a and b n, okay, it is given, that means a and b, and now initial one a and b, then you can find x middle point and continue this one. If you continue n number of iteration, this is the iterative formula. Okay, so and what we are doing, we are considering this concept that the product of the functional value at that and n points should be less than 0. Okay, so this is the one figure. In the next slide, I will draw one figure. Okay, y equals to f of x. Now the point is a comma b. Say this is the interval. How many solutions are there?
4, sir.
How many? 2.
4, sir.
4 solutions are there.
4, sir.
4 solutions are there. Fine. So find that one. Okay. And if you consider this one, what is this line? What is the name?
F of A.
Mathematical. Okay, f of a. Fine, f of a. And what is this one?
F of B.
F of b. Now write down f of a into f of b. What is the answer?
Greater than 0.
Greater than 0. So what is your conclusion? There's between a and b, root does not exist, correct? But according to figure, how many solutions are there? 4. So 4 solutions are there, you are telling no solution. So then how can you how can we describe this concept? Anyone? Try to describe this one. What
Sir, I think we should look up to the maximum point, sir. Lowest, least point and to the maximum point, sir.
Okay. Fine. Very good. Actually, in mathematical concept, that one. If you go back to the previous one, there only one root exists, correct? And you just check the graph y equals to f of x, what I have drawn. It is increasing or decreasing, correct? From here we can say it is increasing, from here we can say this side decreasing. Yes or no? So I think it is actually, or else we can say totally increasing. That is also fine. If you consider the negative part, this part also, x1 to x2. So ultimately, or else you can say, if it is x-axis, y-axis is here, then only. Otherwise, forget about this one. Just see the function is increasing, correct? Y equals to f of x is increasing function throughout the x. So for increasing function or the function y equals to f of x, okay, for this type of function, what is this one? F dash x. Anyone?
Slope of the curve, sir.
Slope of the curve is always
Positive, sir.
positive. So increasing function. What about decreasing function?
Less than 0.
Negative, sir.
Less than 0. Fine. So you just check the next one. Why I am telling? Sorry. Just check this one. Here the graph is increasing, correct? Should I change the color? Okay. Here the graph. The graph is, what type of graph? This one? Increasing. And after that, this one? After this one is okay. After that, from here to next point, different color. What is that?
Decreasing.
Decreasing.
Okay. Once again, this one.
Increasing.
Increasing.
Fine. This one decreasing. Correct. So what is happening actually? Function is decreasing, increasing, decreasing, increasing. So it is not strictly increasing or decreasing. Correct now? So if it is strictly increasing, then it should not come down. Correct? So in this case, okay. So what is that actually the case is? So here A to B infinite number of solutions are there. That's why you can't find this point. And the function is not actually continuous and continuously differentiable. Okay. That means if you consider the whole interval A to B right now here, according to this one, f of A into f of B is greater than 0, and our conclusion based on the concept that there we should not have, we can't find any solution, any root between A to B. But according to the figure, it is at least 4 solutions are there. Okay. So now I will change the B. This is the B, say, instead of this one. What is your conclusion? F of A into f of B.
Less than 0, sir.
Less than 0. So only one root exists.
At least one root, sir.
At least one root exists. Okay, at least one root exists. Okay, now question is, okay. Huh? What, 3 o'clock? Okay. So at least one root exists. When at least one root exists. Clear now? So now, but according to the figure, you have 1, 2, 3 solutions. How can you identify? Okay, if more than one solution exists, you have studied, I think so. Can you answer the name of the technique to identify the more than one solution? What is that procedure? What is the name of this procedure? Something starting with D. Something, have you studied that one? No, correct? No, you have studied, I know. Huh? 3:15. Any outside fellow is there? No. Inside only. Anything you can do.
Another meeting 3:20.
Okay. So that one actually Descartes' rule of sign. You have studied or not? I think you have not studied. Okay. So at least one root is there. Okay, that one actually. So no, we will not discuss here then. Okay. So at least one root is there. How many positive root and how many negative roots are there? You can find using the concept Descartes' rule of sign. Okay. Based on that, you can check how many roots are there. Okay. Since you have not studied that one, we will not discuss here. But the concept is, okay, from here to here, one root is there. To overcome this difficulty, okay, that means initially from A to B here, okay, no solution exists. Now from A to B, new position, okay, at more than one root are there. Okay, now. So what will be the case for that type of thing? Okay. So now next. Okay. So now we will discuss 2 parts. Okay, now. Then we can confirm about the number of solutions. Let f of x is continuous. Okay. Let f of x is continuous. Okay, and continuously differentiable and continuously differentiable. Ma'am, come.
Just 1 minute, sir.
Yes, your turn.
Sir, Friday we have working with the
That today only we discussed.
We'll take some.
Sure.
Both of you guys, sir.
Sure. Hello, f of x is continuous and continuously differentiable. Okay. Differentiable up to sufficient number of time. Sufficient number of times. Number of times. Okay. This is first case if we consider this one. So that difficulty we can overcome using these two. Second one, let f of x equals to 0 has no multiple root. No multiple roots. Okay. In a sufficiently small interval a comma b. It may be closed interval also, a comma b. Okay, that is if alpha is a real root, if alpha is a real root, okay, of f of x, okay, equals to 0 in a comma b, okay, then f of alpha equals to 0 and either f dash a x less than 0 or f dash x greater than 0 in a comma b. What is the meaning of these two? Underline one. F of
Increasing or decreasing functions.
yeah, fine. So already we have defined that the f of a comma b is a very small interval, a sufficiently small interval. Okay, so that means if it is a small interval and the function is increasing or decreasing, then it is a rare chance to come down again and cross the x-axis or touch the x-axis. Fine. So these two are the conditions for the bisection method. Okay, or we can say that to trace the location of roots of the function f of x or the equation f of x equals to 0. Clear? I think you have this concept, but mathematically you have not actually studied this one earlier, correct? So next page. Okay, already we have discussed regarding the method, bisection method. Okay, so concept, but now okay, now I will write the bisection method. Okay, just steps. Okay, so it's once again it is a repeated application of that that working formula. What is that working formula? I have already written, but once again I will write. So what are the steps? Step 1. Okay, then we will consider one problem. Step 1. Okay, first it is given that f of x equals to 0. You have to find a root of the equation. Okay, this is already defined, correct? Now this is the question. So this is the question, and now step 1. What is the step 1? Now find an interval an comma bn. Write up is really bad. An comma bn. Find vn where f of an into f of vn is less than 0 and f dashed x, okay, maintain same sign, maintains same sign. What is the meaning? Either increasing or decreasing. It should not be okay. One times f dash x is 0, another time f dash x is one times positive, one times negative. If you consider small interval, okay, that means the interval is a n and bn. Okay, if you break it, okay, now, or if you divide it, okay, again in the small interval it should not sometimes increasing, sometimes decreasing, or in between it should be the same sign, either positive or negative. Okay, fine. So this is the case. First step, sorry. Second step. What is the step 1? What is the meaning actually? What we are doing here in step 1? The step 1, identifying the interval of x where at least one root exists, correct or not? So that is an and bn. According to my figure, okay, this one you are identifying a and b, initial step, a and b. You can remember this one, correct? Now next, what is the next step? Now step 2, write small n, number of interval. Okay, what is this one? Now number of interval or iteration. Number of interval or iteration. Okay, now then what is xn? This number of an, vn already you have from the previous step, this two, then comma xn plus 1. I have already written earlier, correct? Now an plus vn by 2, this one, correct? And one more, okay, f of xn plus 1, this one also. What is f of xn? This value also. Why? Now based on this value only we can find the next interval. We can able to identify the next interval. That is step, say, 3. What is step 3? Any doubt, anyone? Okay. Now we have to identify the new interval. Okay, new interval. So new interval is this one, right? Okay, the positive or negative sign with an, is it positive or an, it's negative. Okay, anyone. Accordingly as f of a not greater than 0 or f of a not less than 0, correct? And negative or positive, whatever I have actually discussed, that one only we are writing in mathematical term or in a word. Okay, sign with vn as vn negative or vn positive. You can write a naught or b naught also. Sorry, n, bn is according. Okay, now. Okay, accordingly as, okay, f of v naught less than 0 or f of v naught greater than 0. So based on these two, okay, based on these two, this one or this one and this one, sorry, this one and this one. Say f of a naught is greater than 0. Okay, then you have to choose f of b naught less than 0. Otherwise, this two product will not be 0. You get less than 0. Or if you consider this one, then you have to choose this one. Or if you consider if it is f of a is less than 0, then f of b naught should be greater than 0. Then only one root should be there. Okay, actually that way. So now, if we consider the next step, okay, step 4, final step. Okay, I will not write all this term. Okay, I will write in a mathematical form, short form. Okay, how to write? How to write x n plus 1? Okay, so what is that one? For that, two schemes are there. Okay, that means if n equals to say first iteration, then x 1 plus 1, that means x2. What will be the x2? Or if it is n equals to 1, sorry, n equals to 0, that means x1. That will be what is the x1 value. Okay, so that for that purpose, two schemes are there. Okay, scheme 1 I will write. I'm not going to write in details like earlier steps. Okay, now necessary. It's better to write in short form, that is in terms of scheme. Okay, that is one, scheme 1, and another one, scheme 2, like that. Okay, let us see what is that one. Now, when f of a naught equals to greater than 0 and f of v naught is greater than 0, sorry, less than 0, then you choose a naught, v naught. Okay, or else another option, scheme 2, f of a naught, okay, is less than 0 and f of v naught is greater than 0. So you just see the new one is actually the new x1. So say n equals to 0. So what is that one? Now this is the scheme. So what is that one? What is x0 plus 1? That means x1, it is a naught plus b naught by 2. What is this a naught? Either this should satisfy this scheme or this one, any one. But it should not be like f of a naught. We can't consider this combination. Just see. We can't consider these two combination. The green one. These two combination we can't consider. So either this combination you have to consider or this combination mathematically. Okay. So what is actually we are doing? You just see the next scheme. These are the 4 steps. Now mathematical form. Okay. Say you have this one. Mathematical form but graphical representation only. Okay. Sorry. Okay. As per our, this is your A and B initial. Then I will consider one problem. Okay. So f of A and B both are satisfying f of A, the condition. Okay, this one. Okay. Then what is the x1? Now say this is one is x0 and this one. So a naught plus b naught by 2. Okay. So let us consider this one. This is as so, but graphically it's not correct. I will see. I will consider almost. Okay, clear then. Very close. Okay, now this one. Okay, x1. Now if you check f of a naught into f of x1 is less than 0. So the solution actually in this case a naught comma b naught. Now you are changing from, so x2 is a naught plus x1 by 2 next case. Before that you write the root lies between this one. Now x2 is this one. So x2 is say half of this one, half of this length. Okay. So x2. So what is x2? Now f of a naught into f of x2 is greater than 0. So this condition we can't consider this scheme. So f of x2 into f of x1 is less than 0. That implies, so just see the interval x1 or x2 comma x1. Fine. So just check what actually I have written. I will discuss now. Okay. I will discuss now. A0, B0. Okay. 3 schemes are there. Okay. 1, 2, and 3. Just see. I have segregated 3 schemes for your understanding. So first one is A0, B0. Next one, X, this one is replaced. Next one is, this one is replaced. So how we are replacing the interval? Based on the sign of f of a. So initial case A0, B0, now the right hand, the upper limit change, first case. Second case, lower limit change, and so on. But it is not like first upper limit, next lower limit. It's totally depend on the sign of this one. You just check, okay, how we are replacing. Okay, so based on that one, and what the position is, say B0 to x1, B0 to x1. Okay, if you check B0 to x1, okay, both are negative. That's why negative is replaced by negative. Just check, f of B0 is negative, positive, f of x1 is also positive. That's why positive is replacing positive. But in this case, f of A0 is negative and f of x2 is also negative. Correct? So we are replacing the positive one, negative one by the negative one. Any doubt here? The next, actually, we are going to consider one problem. Okay, so if it is clear for you, then it will be easy to find the solution. Okay, I will consider one problem. Okay, so write down the problem. First problem, example 1. Okay, find the root. Find a positive root of x cube minus 3x plus 1.06 equals to 0 using bisection method. Using bisection method. Okay, that up to this one is fine. Okay, correct up to 2 decimal places. This part till now I have not discussed. Okay, I will discuss considering this problem. Okay, now. Okay, so let f of x equals to x cube minus 3x plus 1.06. Okay, so now let x equals to 0, f of 0, what is the answer? 1.06. Okay, and f of 1, x equals to 1, f of 1, what is the answer? Minus 3, 2.0, so minus 3 plus 2.06, so it is minus 4, 9, correct? So it is negative, it is positive. What is your conclusion? That means from this on we can say that, okay, therefore, or thus one root, of course positive root, correct now? One positive root, okay, alpha, say alpha, lies in the interval 0, 1. Either close interval, it will be better to write in the interval 0, 1. Fine. Since f of 0 into f of 1 is less than 0. Fine. So now I will consider one table. Okay, what is that one? Okay, so this is the table for finding the root of f of x. What is the computational scheme? Now bisection method scheme is, okay, bisection method. So what is the rule? That one is, what is that one? Now xn plus 1 equals to an plus bn by 2. Okay, so this is the one. Now the table. Okay, so n, point n, then an, is it positive or negative? We have to check. Say first one is positive, so an, this is say an, say this one is say bn. So for this problem, an is positive but bn is negative. Okay, if it is reverse, okay, then you can, here also you can write in reverse form, no problem. Okay, so now xn plus 1 equals to an plus bn by 2, and finally f of xn plus 1. So what is f of x? If you go back, so x cube minus 3x plus 1.06. So say first one, n equals to 0. So if you n equals to 0, you will get x1, correct? And that is a0 plus b0 by 2. So what is a0? a0 is 0. I will go back. Okay, so a0 is 0 and a0, it is a0 first case. Okay, so 0 comma 1, it is a0, this is b0. Okay, so 0 and 1. Next, 0 and 1, correct? And divided by 2, a0 plus b0. So 0 plus 1 by 2. This case I am writing. Next one I will not write. Okay, now f of 0.5. Anyone? What is f of 0.5? Quick. So it should have been a calculator right now. So just put 0.5 instead of here it is, for x equals to 0.5. What is the answer? Three, 1. Fine. What is the nature? Negative or positive? Negative. Which one should be replaced? This one or this one? Bn. Fine. So you just see, for n equals to 1. Okay, I am writing here n equals to 1. So what is 1? So x2 you are going to find. So a1 plus b1 by 2. Okay. So but before that, here it will not change. This one is changed by this one. Okay. So 0.5. So what is this one? x2. Now sum of these two divided by 2. So what is the answer? 0 plus 0.5 by 2. So 0.25. What is f of 0.25? (0.32), correct. Okay, no problem. 0.32. It is negative or positive? Positive. So for n equals to 2, so this one we should replace or this one we should replace? Positive one we should replace. So this one 0.32, it's remaining same. x3, I will not write again x3. We should not write all these things. So 0.32 plus 0.5 by 2. So the answer is, what is the answer? So answer is 0.5 and 0.32. Oh, sorry. I have read No. I have written this one is mistake. This is the f of x, but it should be replaced by x2, correct? Na? 0.25. So this is the mistake I have done. It should not be 0.32. It's a 0.25. This one. We just take this one is replacing. This one is 0.25. So this one should replace. Correct? Na? So it is 0.25. So the answer is 0.25 plus 0.5 by 2. So it is
375.
Yeah, 0.375. So now again you have to find 0.375. What is the answer? Minus 0.01. So it is negative. Correct. So third iteration 3. So positive should not change. This 0.25. This one should change. Okay. Na? So x3 should be here. So it is 0.375. So x4 equals to 0.25 plus 0.35. Okay. So what is the answer? 0.25 plus 0.375 divided by 2. So
0.3125.
3125. F of 0.3125 equals to it will take time, I know. Okay, do it. .15. So positive. Okay. So positive means fourth iteration. So positive should be replaced. So 0.3125. Okay. And 0.375. x5 equals to 0.3125 plus 0.375 divided by 2. .315. Okay. 0.315. So f of 0.315 okay equals to, actually we can stop here. Okay, just wait. You just find it, then I will tell you. 0.1. So it is again positive, but how many iterations we have to do? That is the question. Should we continue here again? So positive. So positive one should be replaced. So 0.3315, 0.375, x6 also we can find. Okay, fine. I will not going to find anymore. When we should stop? Actually, if you go back, okay, correct up to 2 decimal places. Correct. That means the value of x of 2 successive iterations up to 2 decimal places, it should be same. Correct na? So now you see, this is our computational scheme and the answer also. So x3, x4 and x5, 0.31, 0.31, both are same. So we can stop here. Okay. And we can say that the recorded solution is, or root is, okay, required root is x equals to 0.31. Correct up to 2 decimal places. Okay. So it is not exact solution. It is a correct up to 2 decimal places solution only. Okay. So this is the procedure, 2 decimal places solution, this one. X equals to 0.31. Okay. Anyone having any doubt? Okay. If you don't have, so write down for practice purpose. So this table, previous one. Okay. This is the computational table. You can write For finding, instead of that one, you can write the computational table. Okay, or you can write the table for finding the root of f of x. With the scheme also you should write xn plus 1 equals to xn plus bn by 2. Okay, so next I will give you two homework, two only, and for practice purpose. Okay, no need to send to me. Okay, first one. Okay, find the root sorry, find the root of log of x equals to cos of x. Okay, or of course it is bisection method. Okay, na, using bisection method. Okay, then up to, correct up to, okay, up to three significant figures. Okay, next one is problem 2. Okay, find the root, okay, find the negative root of 10 to the power x plus sine x plus twice x equals to 0 using bisection method. Okay, up to three okay, up to 2 decimal places. Fine. If you have any doubt, you can ask. Otherwise, these are the 2 homework you should complete before your next class. Okay, fine. If you have any doubt, you can ask me now. Otherwise, you can leave the meeting.